So we're now opening the webinar. People are coming in.
Wonderful.
Just going to give it a couple seconds. Okay, so well, welcome, good afternoon. Welcome to this other presentation with the Marketplace by Windor. Today we have Dan Garnett, who's Sales Director with Adfast, who's gonna let us know a little bit more about sealants. So, without further ado, I'll just want to thank Quanex, official presenter of the Marketplace, and then I'll let you take it from here.
Wonderful, thanks much. Good afternoon, everyone. As was mentioned, my name is Dan Garnett. I'm Sales Director for Adfast, and very much looking forward to spending the next hour with you reviewing some information about sealants and their applications and selecting the proper sealants. So this presentation was made especially for the Windor 2020 event. So if you have some questions along the way, please throw it into the chat, and we'll be happy to address them as we go. And we'll go ahead and get started. And one last thing, just a little bit about Adfast, just to give you some additional perspective. We're about a 40-year-old business. That we are a manufacturer of sealants, adhesives. We provide a lot of complementary items like foams, et cetera, into commercial construction and also the industrial marketplace across all of North America. So we have about 150 employees, and I'm actually coming to you from our Indiana location. So thanks for joining us, and we'll look forward to your questions as we go. Okay, so what we're going to do today to accomplish is we'd like for you to learn about the different families of sealants, and of course how to choose the correct product for each application. There's so many different sealants that are out there, so many different applications, and it's not just a select one and go to town and use it across all applications. It's very important to select the right one, and so that's the primary objective for today. So we're going to look to describe some of those families of sealants and understand how to use or when to use one over another. We're going to take a look at some curtain wall projects as it relates to structural and non-structural silicone sealant applications. We're going to spend a little bit of time discussing why UV light is such an important factor when it comes to the deterioration of some sealants, but not others. And then we're going to take a look at how to implement some procedures for installation, for proper surface preparation during the installation component. So here are a few of the quick bullets of the content of this presentation. Once again, different families of sealants. We're going to discuss in depth some of the benefits of using a silicone versus a polyurethane. Both are moisture cure technology, but there's some advantages over using a silicone over a polyurethane, and we'll dive into those a little bit. We're going to discuss a few of the different types of silicone families. Many people think of silicone as a silicone. There's actually different types, and we'll take a quick look at that. Of course, how to choose the right application for each application. We're going to take a look at some of the ASTM testing that takes place to make sure that these products are meeting the needs of the application for temperature, for elongation, for compression, for the shore or the hardness of the product, for the adhesion qualities, etc. So we'll review some of those tests. Once again, the structural versus non-structural, there is a difference there, and we'll need to make sure that we identify that. And then beyond that, when we get into the surface preparation and the actual installation procedures, we want to take a look at the importance of tooling the product, and prior to even tooling it, using a backer rod. And what type of backer rod is best to use. We'll look at a few various designs of different joints. We'll review some on-site testing that can be done at various projects, and we'll talk about compatibility and also for the very important component of specifications as it relates to sealants on a project. So many of you, if you're like me, have walked into a box store or your local hardware store, or maybe a local area distributor, and you come across this, and you immediately start thinking maybe you just want to exit the G.A.O because the decision's so tough. How do you decide which one to use? There's so many of them there. Are they neutral cure? Are they acrylic? Or is it a polyurethane? Is it latex? Is it paintable, not paintable? It's really difficult when we come across a situation like this to understand what type of product to use, but it's very critical to actually understand this process and these products to be able to make the right determination so that it's not going to delaminate, crack, or peel and cause issues with water and moisture, et cetera, on down the road. So as we start to look at some of the different families of sealants, one of the first things we're going to take a look at is those sealants that actually are using the drying process of evaporation of either a solvent, so if it's a solvent-based sealant, or water. So acrylic latex would be an example of a water-based, and then you've got your thermoplastic and butyls, which can be more solvent-based. And so what happens is that you see the picture here on the right-hand side of the presentation, where these actual joints in mock-up, if you will, were actually set. They were filled to the brim and then tooled. And over time, you can see that you're getting 30 to 40%, maybe in some cases 50% a loss of the product during that evaporation phase. And what happens here is you're getting micro cracking, you're getting some tension cracks, and also is going to start to get some delamination of the product. You can see, especially on the far right, some delamination there. And that's going to allow for moisture, air and moisture and et cetera to actually penetrate that joint. So it's very important to understand, while there are some uses for these types of technologies, especially maybe an acrylic, there are much better technologies that are now available out there. So one of the things, if you are using a thermoplastic sealant, it's important to note that we need to make the joint in a convex, or the bead rather, in a convex way. We don't want to shape this because it is, as we indicated, it is going to have that shrinkage over time. So you want to make sure that it's convex. Now, when we get into a neutral cure, moisture cure silicone or sealant, we'll actually show that you can do it in a concave fashion because you're not actually losing anything. There's no shrinkage in the vulcanization or curing process. Here's an example of a thermoplastic sealant that's been used. This picture has been taken 8 years after the installation. And as you can see, it's quite a mess. We've got a lot of cracking, a lot of delamination, a lot of areas for, really just across the entire joint is really pulled away and is allowing moisture and water to get in through that joint. So this is one of the factors to keep in mind. And in this particular instance, the wrong product used for this application. So as we move on to newer technologies, so with those that are sealants that are actually drying by moisture are sealants such as silicone, polyurethanes, and then hybrids. There are a couple of examples of a hybrid sealant would be a modified silane polymer, or the silane terminated polyether, STPE. So in today's presentation, we're primarily going to be focusing on the differences between silicone and polyurethane. These are the ones that are most common in the marketplace as it relates to commercial and residential construction. So as we dive a little bit into those differences between a silicone and a polyurethane moisture cure technologies, we'll right away notice some really important things. So as it comes to structural applications, if there's a specification for a structural application in which the window units, for example, panels, IG panels, would need to be affixed to a building, to the mullions or to the framing of a building, you would, of course, it's a requirement to use a neutral cure silicone, a structural neutral cure silicone for that application. You cannot use a polyurethane. When it comes to the exterior weather seal and some perimeter sealing, there are, polyurethane's been around for a long time. It's common out there in specifications. We are working to flip the script here, because a silicone, while it is also a polyurethane, has about as much as 3 times life expectancy of the polyurethane. And one of the reasons why there is such a vast difference in the life expectancy of a silicone technology versus a polyurethane technology is just in its chemical makeup. The chemical composition for a polyurethane is actually organic in composition. It is, there's the carbon bonds there that are actually going to start to degrade over time with UV light. Silicone is actually an inorganic compound and will not degrade. Ultraviolet UV rays will not be the main cause of a degradation factor. So this is an example of one of the reasons why you start to, after 5, 6, 7 years, if you're on the south side here in the northern hemisphere, on the south side facing a wall of an exterior building and getting a lot of sun, maybe it's 2 or 3 years you start to notice some micro cracking. So it's very important to understand the differences in composition and the benefits of using a silicone. Here's another example. We've got silicone and polyurethane here. And over time, you can see that there is that cracking that goes deep into the joint, whereas a silicone keeps the integrity of that particular application intact over time. One of the reasons why many polyurethanes have been used in the past was for the benefits of adhesion, especially in porous substrates, masonry, et cetera. But there are actually, with the newer silicone technologies, there's many different types of neutral cure silicone products, whether it be low modulus or medium modulus, standard modulus products that will actually, some of them will not require a primer for those type of applications. And so we'll take a look at that in another slide or two. Here's one other example real quick on the consequences of UV lights on a polyurethane sealant. You can see a lot of cracking here, and moisture and water will be able to get into that joint very easily and unfortunately very quickly. Another example here. A lot of cracking, and most of this is going to be from the UV light consequences. Here's a great example. I believe this picture was actually taken by one of my colleagues as he was getting ready to give an in-person, back when we could do those, presentation to a group of architects and engineers. And as he was walking in, this is a fairly new building, took a photo of this. I think it was somewhere in the range of 3 to 5 years old, and it already has this level of cracking. I'm sure that looked like a perfectly wonderful joint prior to the UV light causing some issues there. So as we move on to some of the other things to keep in mind is actually going to be the environment, the conditions in which the application is taking place. One of the most important parts to understand is that silicones can be applied down to negative 40 degrees Fahrenheit. And it is important to note that vulcanization of the curing process does dramatically slow down for all one component sealants when the temperature drops below a freezing point, but it can be used. One of the difficult aspects of using a polyurethane as in lieu of a silicone is that it's actually very hard to get out of whether it's a cartridge or a sausage format. Colder weather makes it very difficult to actually gun and to get into the application. And then what we find happening is that many of the contractors who are doing the installation will actually heat up the product in a heat box, a lamp box, or whatever you want to call it, and they'll heat it up to 60 to 70 degrees Fahrenheit. And in doing so, they are actually making the product easier to gun, but then they're putting the product that is now 60 degrees onto a substrate that might be 32 degrees or 0 degrees, in which case there's going to be some moisture. And with moisture, it comes the possibility for, or increases the likelihood of delamination, of it not adhering correctly to the substrate. So it's very important that as we go through this, you want to make sure that the sealant that's being used is actually at the same or close to the same temperature as the substrate that it's going onto. So once again, this is just a quick recap that silicone can be applied throughout the year. It's an organic sealant. I'm sorry, the organic sealants that we just discussed would need to be heated in order to be applied, but that we just discussed why that would not be an ideal scenario to go through. They need to be the same temperature and never apply to sealant in weather conditions where condensation or precipitation such as rainfall, freezing rain, snow, fog, anywhere there's a lot of moisture or condensation on the substrate. We want to make sure that the surface is free of frost and condensation. And of course, when we're discussing silicones or polyurethanes, they're both moisture cure sealants. And moisture cure sealants are going to take humidity, from the air in order to go ahead and cure. And so the lower the temperature, typically, we're going to find less humidity, relative humidity in the air. And so it will actually take a little bit longer to go through that curing process. So the same goes on the flip side, right? So we just discussed some of the important things to consider as it relates to cold weather, whether it be the temperature of the substrates or the material, the gunnability, et cetera. But it's also important to take a look at again, the other side of it where it's super hot. In Canada, we're not going to have a whole lot of 110-degree weather like you might have in Death Valley in Southern California or in Arizona or Florida, where have you. But there are some hot days and where it makes, because again of its chemical composition, it actually becomes much less viscous, and it makes it much harder to apply, especially in your vertical applications, and to get a nice looking bead to make that joint look real nice and for it to do what it's supposed to do, which is to stay in the joint. So one of the other things that we'll take a look at is the drying time. So a silicone, we talk about tack-free or skin time. You're actually, and this is basically where you can apply it, and then you can come back, and if you can touch it and you can pull your finger off and the material is not actually coming off in a large amount on your finger, then that means it's skinned over and it's starting the curing process, which is actually super important, because if we're on a job site conditions where there are a lot of things floating around in the air, there's a lot of other chemicals and other products, there's dust, there's debris. We don't want that to land and then actually affect the integrity of that application. We want to make sure that you apply it, you tool it, you get the application done, and then it starts to do what it's supposed to do as soon as possible, which is to start the curing process, so that we're not absorbing in other chemicals and dust, et cetera, from the atmosphere on the job site. And you guys, you can see here a polyurethane, very, very, very long drying time or tack-free time. As mentioned earlier, there was some perception in the marketplace about polyurethane, being used as an adhesive, especially on substrates that might be porous. And the neutral cure silicone of today, in the last decade, quite frankly, it has brought the adhesion component to be as good or better in many cases than a polyurethane. There are some situations where a primer would be recommended. That's why you would always go to the manufacturer to ask for a consult if you do have any questions about a particular substrate. But by and large, a lot of these are both one part sealants, and you would be able to have great adhesion results on many of these, including masonry. You can see here that I referenced earlier, both are a 5 out of 5. And then there's several where there's an advantage, steel and PVC, composites, fiberglass, et cetera, where there's actual advantage to a silicone in terms of adhesion over a polyurethane. So just some general things to keep in mind as you're considering the applications that are going to be important to you on your project. So now we'll take a look at a couple differences of silicones. So we mentioned earlier a couple different types of products. When we look at silicone, we want to identify the difference between the neutral cure silicone, which is used in specifications for architects, engineers, for various application, commercial and residential applications. But then there's the acetoxy silicone. So if you've been in that aisle, that picture that I showed you earlier, where you've got all those sealants on the wall, it probably smelled like vinegar. There was probably a lot of acetoxy silicone that was in that aisle. We find that on a lot of box stores. because that's where you go. You go to a Home Depot, Lowe's, Menards, what have you, and you're going there for a home improvement project like a kitchen or a bathroom. And the acetox is going to be great for mildew resistance. It's going to add some, that added benefit of offering the mildew resistance. But it's very limited in terms of the type of adhesion you're going to get. It's acetic in content, so you've got to be careful with with compatibility for substrates, and then you're not going to get the elasticity or the shelf life. So if when we're doing joint sealing, whether it be for perimeter, et cetera, we want to make sure that we're getting the most elasticity as possible. There's many specifications out there that ask for a class 50 or better. And so class 50 meaning 50% compression and 50% elongation. So with an acetoxy silicone, you're getting about at most 25%, which is not going to quite get you there. Very little to no corrosion on most materials for silicone, for a neutral cure silicone rather. And excellent, as we looked at on a previous chart, excellent adhesion on many different types of materials, and is used in residential, commercial, and industrial applications. We actually have a lot of customers, and as do other manufacturers, but just in the realm of the industrial piece where there's a lot of OEM manufacturing, et cetera, where neutral cure silicones are used because of their the large number of applications that they can be used for, above and beyond kitchen and bath. So let's move on now to take a look at how to choose the right product. Here's just a real quick rundown on some of the important considerations. Doesn't need to be painted. What type of substrates are needing to be sealed or adhered to? What are the conditions of the application, including the environmental conditions, weather, sunlight, et cetera. The size of the joint will determine very often if you're going to need to use a 1 or a 2 component sealant. And then, of course, compatibility is important, which is something that we've addressed on a few previous slides. So as we look at the American Society for Testing Materials, this is what you would see in this is the typical nomenclature that you would see in a specification for a project. And what you're looking for here is, the C920. This is just the standard specification where you would find this is the C920 for elastomeric joint sealants. The S or M is going to be that single component or multi-component. There are some advantages to doing a multi-component. If, for example, you can have a prefab shop where you can utilize a multi-component sealant and prefab the framing, et cetera, and then, but what would be required. So the benefit of that is, for many projects, is that you have the benefit of controlling the environment, the temperature, you may get some economies of scale in terms of production, et cetera. But then cranes are needed to be used on the job site in order to install. So more often than not, much more often than not, we actually see the single component sealants being utilized. So probably you'll normally see an S here. And then we get into the non-sag or sag. So a non-sag would be something that can be used on the verticals. So we saw that picture a little bit earlier, which highlighted the importance of using a silicone or a polyurethane for your verticals, especially in warm weather. So there can have that non-sag capability. You want to go into the joint and stay in the joint versus having gravity do its thing. And then we get into the class system, and I've kind of referenced this already, but this takes a little bit closer of a look. So once again, it goes, ranges from a 12.5 to 100/50. And the 12.5 or 25 or 35, for example, would represent a lot of your non-specified applications. And even into the 50%, we have a lot of builders and designers, architects, engineers that are now even recommending the 50% or greater across the board. But what we're looking at here is if it's 25 or 50%, for example, that means there's going to be 50% compression and 50% elongation of that material. And so you're getting that elasticity that will be there. And then when you get to the 100/50, that means there's going to be a 100% elongation and 50% compression. So we're able to compress the material down about 50%, but we're able to stretch it about 100%. And then, of course, the type of substrate. Is it glass, is it aluminum, masonry, et cetera. So that's something to keep an eye on as you see that you come across the ASTM or this nomenclature and specifications. So with ASTM, this is testing, right? So what type of tests are being done? Here's a UV light chamber that helps to accelerate the impact of UV light on a particular product, and then it can be temperature controlled beyond that, and humidity controlled, et cetera. So we have these chambers where the testing is done with advanced UV light to help speed up the process. ASTM D412 is a vulcanized rubber and thermoplastic elastomers tension test, where they're actually, and I'll show the inside of this here in a moment, but you're actually going to put a specimen of the sealant into the grip of traction, begin by separating the grips at a constant rate of tension. And then at the break point, we're going to measure the elongation and also the tensile strength. And that will help determine the ultimate tensile strength, which will be listed. And very important to note this, because some manufacturers out there will note this differently on their products. You want to note that is it the ultimate tensile strength? That should always be provided. So here's a closer look at that particular test where we're pulling this sample apart from one another for the break point. 719 is a standard method of adhesive and cohesive testing. Again, elastomeric sealants under elongation and compression. So we're doing motion here, cyclic motion rather. So many different cycles, also known as the Hockman test, Hockman cycle test. And what that does, it gives us a percentage of elongation and compression that will determine the class that we referred to earlier. So once again, getting that 50% elongation or compression or greater is the ideal place to be. And here's an example of that. And you can do various substrate materials, et cetera. But when you're getting these cycles taking place, you're getting, you have the opportunity to go through the compression and the elasticity or elongation of the product and how it manages on that particular application, that particular type of substrate. So when we look at D2240, more commonly C661, this is a shore test, okay? Shore meaning the hardness of the material. Typically what we're gonna find, and I've referenced earlier in the presentation, are the differences between a structural and non-structural sealant. And in a structural sealant, you're going to find that it's used more often. While it does seal the joint, it's actually used primarily for adhesion, structural adhesion. And it's going to have a much harder shore or hardness. And what's used to determine this would be the durometer. And a durometer is a very simple tool that has a pin that presses into the sealant and will actually give the rating. So a weather seal or a perimeter seal that is non-structural in nature will be softer. It's going to allow for more elongation. And as we'll get into a couple of the joint designs, we'll share about the importance of utilizing a structural sealant in the application that should be used for. And wherever possible, always use a weather seal that offers more elongation for your perimeters that are non-structural in nature. As we look at comparison of products on a data sheet, you can see here that it's important. You've got your ASTMs listed across the left there, along with some of the things that we just identified, like the elongation, the ultimate tensile adhesion, et cetera. And what we're looking for is you're seeing the same test plus the same test being done with the aging factor, or whether that's a UV light, et cetera. So we want to make sure that we're getting several different samples of testing across these products. So we'll start to dig a little bit deeper now into structural versus non-structural applications. With a structural silicone, this is going to be a 1-part moisture cure, non-sag, odorless, et cetera, for structural. It is a requirement, for several different joint designs to use a structural silicone. We're going to take a look at, there's 2-sided and 4-sided vertical horizontal applications. on curtain walls, and also in manufacturing for reinforced panels and structural glass. So a structural silicone is going to adhere to glass and the structure. It's going to allow wind loads to be transferred to the structure, and it must be strong and flexible to allow that movement. Especially, you think about Hurricane Alley or Hurricane Lane or Tornado Alley. These are places where high winds are going to be, at least in the southern parts of the U.S. And we need to be able to make sure that we have the right product and the right joint configuration to make sure and allow that strong and flexible movement. And then, of course, one of the other important pieces is to make sure that when we put something in there, when we're putting insulated glass panels onto a 52-story high-rise that's going to have long life expectancy. We don't want to have to get back to it. So I won't get into the nitty-gritty of this particular slide. This is determined by an engineer of record for a project, and it's going to be very regional. So once again, in parts of California, for example, here in North America, there are earthquakes, and in Kansas, there's tornadoes, and in Florida, there's hurricanes. And there's obviously a lot of varying different types of weather conditions, especially high wind can be possible with storms in Canada, across all of provinces of Canada. So an engineer of record from that region would need to determine what type of joint configuration there needs to be. And then the joint configuration will then determine what type of depth of structural silicone will need to be used to perform that. So just real quick here on some, this is an example of a four-sided application where you have, all of these panels are actually being chemically affixed by a structural silicone to the building. And once again, it has to be strong enough to withstand the wind, the movement, et cetera, and be able to transfer those forces onto the structure of the building versus having the paint itself take the brunt of it. So you'll see here there's setting blocks that are in play. There's temporary pressure plates that are put in play to allow for the curing process. And we need to make sure that all installers of this understand not to actually remove pressure plates for about 21 days making sure there's the right conditions in terms of temperature and humidity to allow that product to fully cure, and then the pressure plates can be removed. As we take a little bit of a closer look, there's a few steps here that will walk us through it. So you've got your Mulliner frame, building framing there, and then there's going to be your glass panels there. And so there's a spacer that's going to be put in that's going to help maintain a consistent joint there to be able to get the right amount of structural silicone adhesive into that joint. And you're looking for the right depth and the right width. So the width of that particular spacer needs to be appropriate considering the joint design and requirements for that application. But again, it's also where you set it at is going to give you your depth. And as we'll take a look at, you want to be able to have a quarter to a half inch of depth and width of product from the actual mullion or framing to the unit. So once the spacers go in and are set properly, at that point in time, you're going to do quarter to a half inch max of the structural silicone. And once that's been done, only after the pressure plates will have to be intact there until 21 days at 23 degrees Celsius and 50% relative humidity. So it's very critical that we have a lot of installers, trades that will be out there on the projects, and they'll call to us for consult as a manufacturer, and they'll say, hey, we're getting a lot of pressure from the other trades, or we've got this weather coming in, we're holding up the job. It's been 14 days, can we go ahead and remove it? And our recommendation, and will always flat out be no. It's got to go through the curing process, it's very important to plan the the Gantt chart for in terms of project management accordingly to be able to allow for that 21 days at 23 degrees Celsius and 50% relative humidity. Once the spacer has been placed and the 1/4 inch of structural silicone has been applied and cured through 21 days, at that point in time, we'll put a soft backer rod in to be able to prevent a 3-sided application. We need for the weather seal that will go on the exterior to only be adhering to the sealed units. And when we use a polyethylene soft backer rod, the NutriCure silicone that will be used will actually not adhere. It's one of only a couple of substrates that are out there that won't have it, silicone won't adhere to, is polyethylene. And so the polyethylene backer rod goes in, and then the perimeter joint for the weatherproofing joint, weather seal, will go on the exterior. And once again, 1/4 inch minimum is necessary for adhesion. And you'll also note here that there is a concavity to this joint versus with the thermoplastics. You would never want to do that because you're going to have, well, first of all, you never want to use a thermoplastic in this application, but this is one of those examples of making sure you were using the right sealant and then doing the right tooling. So that was what we took a look at just there in the previous picture of the building was a 4-sided. Here's an example of a 2-sided structural silicone. You actually have mechanical fastenings that are taking place structurally on your horizontals. And so where that's taking place, you would not need to use a structural silicone. You would actually use a, you would use the weather seal on the exterior, because on the interior, the frame of the glass is actually being affixed mechanically. On the verticals, however, you would need to use the structural silicone on the verticals and then the weather seal class 50 or greater all the way around the exterior, the perimeter of those joints. Here's an example. We've got several different types of configurations. You've got your 4-sided, which would all be structural. Up here, you have your 2-sided, and then somewhere in between. So once again, where there's not a mechanical fastening, there would need to be structural silicone, and then on the interior to affix the panels to the building, and then weather seal, NutriCure silicone, class 50 or greater on the exterior. So once we take a look at procedure, it's very important that, we've talked a lot about it's been very technical thus far, but what we want to do is also show that as great as the product can be, it's only going to be as good as those who are applying it and applying it correctly. So it's very important to understand, once again, that the surface is clean, doesn't have a lot of job site debris. We recommend 99% IPA, isopropyl alcohol, to use a rag to wipe it on, and then a rag to wipe it off, or to allow some time for it to evaporate and dissipate, to flash off. And then immediately, once that's done and it's clean and dry, we want to don't allow time for more job site debris to land on there, oils from the job, et cetera, where you're going to have the a structural silicone actually adhere to the grit and grime. We need it to adhere to the actual substrate. So then you're going to install the units, fix enough temporary pressure plates to support the regional wind, install the silicone, clean the silicone excess, tool it, et cetera, leave the pressure plates in after 21 days removed. So this is a great bullet pointed version, a recap rather, of what we've just discussed. So we did a deep dive into structural. I don't have quite as much for the non-structural, although non-structural is very common. There's a lot of 1, 2, 3-story buildings out there that maybe have mechanical fastenings across the board and don't have a lot of structural requirements. So it's very common to have non-structural on specified for a product for various applications, such as the non-structural caulking, perimeter seals for doors and windows, expansion and control joints for masonry, and then various different types of seals, et cetera. So non-structural, one of the things that comes into play for this type of technology is, once again, you're going to get typically going to get greater elasticity with your class 100/50 is, as high as you can go there. You're getting 100% elongation, 50% compression. And these are going to be great. It's, low modulus product that would be great for, adhesion on masonry, cement, brickstone, granite, etc. Also excellent adhesion on many other different types of substrates, such as glass, woods, ceramics, etc. So for perimeter joints, once again, we would use a class 50 non-sag sealant that would offer 50% compression, 50% elongation. Once again, offers very good adhesion across the board. And your applications here would be your non-structural joints. And then again, this is ideal for doors and windows and several different siding materials, especially as you start to look into these days. There's the James Hardie or the Nichihas of the world, where you're getting into various different types of cement boards or architectural metals that are being used, where you could use a class 50 or greater perimeter joint seal. Once again, common, this looks to be a residential project here, where you have your perimeter joints around doors and windows, and then you have your expansion joints to allow for building movement, and those would need to be sealed rather with a non-structural. So once it's been installed, let's discuss quickly the importance of actually using a backer rod and tooling it. Very, very great depiction here of what happens without backing and tooling being used. The sealant may be applied, but very quickly you're going to notice that it's not going to provide a lot of coverage for you, whether it be moisture or otherwise. But then let's say that there is a backer rod that's used, we've gotten halfway there, but then we don't tool it. That's not going to, you look at the points of adhesion from panel to panel, from substrate to substrate, that's not going to be good for you either. The ideal scenario is to actually have the backer rod put in place, once again, to prevent the sealant from going too deep into the joint, and to also prevent the three-sided adhesion. And then you're going to put the silicone into the joint, and then you're going to tool it to make sure that you're getting coverage for great adhesion, great coverage across the joint. And once again, with a neutral cure silicone that is not going to quickly degrade through an evaporation process and actually lose 30 to 50% of its material, you can actually start off with a concave tooling. So this is a fairly busy slide, a lot of information here. I won't go over it word for word, but I will highlight a few important pieces. When you're doing repair work or new construction, it is important, we get this question quite a bit, is do I need to remove all the old sealant? Well, the answer is yes. If it's a failing sealant, if it's cracking, if it's been in place for a long time, we need to remove that, because although silicone will adhere to the old sealant, we don't want to adhere to an old failing sealant. We want to adhere to the substrates. And so it's very important to actually mechanically remove all the old sealant when going back through repair work. For porous surfaces, we want to grind that off and get as much of the old sealant off as possible. We want to be able to use an IPA, isopropyl alcohol solvent, to clean. We're going to wait some time. We're going to, if necessary, and again, we can provide, us and other manufacturers can provide some consultation. If a primer would be necessary, install that backer rod, or use a non-stick tape. If it's too small of a joint, you could use a tape that would prevent a three-sided application. Apply the sealant, shape sealant, and then when we're tooling, there's, if you're anything like me, what I used to do around the home prior to joining the Adfast team, it was the finger lick, and then, you would drag it across and hope you're not getting too much sealant, on your fingers, etc. That is pretty rudimentary. It's still very, very common on job sites, unfortunately. But what we're trying to do is educate that you can use a tooling kit where you can actually use sticks that are tapered in many different ways and different sizes. They look a little bit in size like maybe what you would have for a paint mixing stick, but they're tapered and they're different widths, etc., to give you the right joint size. And we would recommend soaking those in maybe a thermostat, et cetera, of 95% water with 5% clear dish soap. And then you're not getting the silicone adhering to it, and you get a great finish. So that's one of the things, little tricks of the trade there to share with you all. And once again, we want to avoid applying a solution directly to the sealant. There's some out there that will spray a Windex. They'll put the sealant on and then spray a Windex over it, and then try to tool over it that way. That's not, we want to mess with the chemical composition, the integrity of that particular application. Not good to spray directly onto something like that. So the tooth cloth method is something I referred to earlier. When you're using IPA, you're going to clean and then you're going to wipe off. Whoops, sorry. Here's an example quite quickly of on the bottom right here of an anti-adhesive tape being used because a backer rod would not fit into this joint. But an anti-adhesive tape would prevent the silicone from going into the joint and adhering to anything behind it. You don't want to get three-sided adhesion because then you don't get good joint movement. And so that's an example here. Once again, you want to have a minimum contact of 1/4 of an inch. Ratio 2 to 1 is really ideal. But once again, if you can just keep in mind 1/4 to 1/2 inch max of your silicone sealant for your non-structural, especially in this case, it would be for your weather sealing, etc. That's the most important thing to keep in mind. Other types of joints, we've got panel joints, and then a joint repair. It is okay to go over an existing joint if cosmetically or aesthetically it's going to be okay for the owner, the architect, etc. But we need to make sure that we're not going over just the sealant. We need to get that minimum 1/4 inch onto these either side of the substrates. Pretty much similar situation across the board. We're just taking the opportunity to show that there are various different types of joints and sealants that would need to be used. But the common theme here is that you're needing to get 1/4 to 1/2 inch of product into the joint and to have it tooled to make sure you're having great adhesive coverage for that application. Splice joints where you've got some potential movement left to right, same sort of situation. You would still use a backer rod and you're still using the silicone seal in the same manner. Double joints, interesting because you're using 2 backer rods and 2 sets of sealant to do the double joint. If, for example, here you have granite over concrete. Here's some examples of joint design. And a good joint example here, and then maybe a bad joint example. We actually got a picture of this earlier of a polyurethane that have been used probably in warm weather where you're not getting the right joint, not the right product for the right application, and then there's too much product being used here. It's you're seeing some delamination, etc. So this is an example of what could look great, especially with color coordination here. And then something that was an attempt at color coordination, but not good in installation. We do offer a test on site. This is a standard pull test where we would come on site to your project to pull either old or newly installed silicone sealants. Here's an example of pulling it. First of all, when you're cutting it, you want to make sure that when you're pulling it off, you still have product that's adhered to the substrate. So you cut along and you pull it, but it's breaking at the product level, not the pulling apart, delaminating completely from the substrate. And then you're going to pull on it to make sure you're getting that elongation and that it's going to stay intact. So this would be an example of it looks to be a passed test. Waterproofing, this is something that's super important as well. As we do testing on site, there's waterproofing testing that's being done where they're showering it with a lot of water. There's wind that can add to it if you get big storms and you want to have both wind and water at the same time. You can see this is simulating that 56 mile per hour wind, and simulating by and large just terrible weather conditions, extreme weather conditions, and want to make sure that the integrity of that system stays in place. The glass panel stays in place, stays structurally adhered to the building, and then also you're not getting water, moisture, etc. into the building. I'll quickly go over this. As if you see membranes being used on a job site that do not have branding, etc. on it, You might question because that means it's probably not been through a Corona treatment. In order for all the branding and anything to stick to your job site membranes, it has to go through a process in which, and I think I've got a slide for it here, where you're actually, it's called the Corona treatment, where you're changing the surface tension level of that particular plastic, so that it will allow, and then within a short period of time, usually within 3 to 6 months, is the time to be able to do the to be able to install a product over it for it to adhere. And once it's there for good, so you don't have to worry about it. But if you wait for a year or longer, it would have to go through the Corona treatment again. So something to be mindful of. Okay, so as we take a look at compatibility, there are, your secondary seals, et cetera, your desiccant for moisture control. These are things that we want to keep in mind in terms of compatibility. Setting blocks, as you can see here on the bottom left, there's setting blocks that were not compatible. So when you get in the neoprene EPDM setting blocks, you can have some compatibility issues. So we'll always recommend a silicone or PVC setting blocks to be used with silicone materials. Here's a perfect example of having some discoloration due to having used the wrong type of setting blocks. As you can see here, this job site is not even been wrapped up yet, and you can see there's already some discoloration here right over the setting block. So something to keep in mind as well. We can, and other manufacturers can assist with looking at compatibility. When it comes to backer rod, it's important to use soft cell, open-celled soft backer rod, so that when it's being installed, you don't puncture and cause outgassing of the closed hard cell backer rod, because it can cause pitting and bubbling of your joint. So the person who did this probably walked away saying it looked great, and then comes back the next day and it looks like this. So we always recommend soft open cell backer rod. Another example of the pitting here. So that concludes the Adfast. That concludes the technical training portion of our presentation. I'll have a few slides to quickly tell you a little about Adfast, and I'd like to open up for a few questions. Okay, so just a minute or two as I go over some Adfast material, and then we'll open it up for questions. We're a manufacturer in North America, based out of Montreal. Been in business since 1981. Actually now closer to 160 employees and many stocking locations across the United States, and growing. We have a wide variety of different types of silicones and sealants and adhesives that are used in commercial construction, residential construction, industrial OEM manufacturing facilities, food facilities for packaging, et cetera. So we talked about acetoxys, neutral cures for masonry products, the hybrids are going to be paintable for interior and exterior. And also we do offer some adhesive products as well, which we didn't get into as much in this presentation. A lot of different formats that it could be used for Adfast, whether cartridges, sausage, all the way up. We don't have it depicted here, but even totes, much larger than the 53 gallon. We have OEM manufacturers who are using pump systems to help create their products that will end up getting into your hands on down the road. One of the really cool thing is that we're now over 300 colors. One of the really cool differentiators for Adfast is that we've got a wide variety of colors and can do so. It can specifically color match to a project and have a quick turnaround and a low minimum quantity requirement in order to have that color for your project. An example of this would be those jobs that we do for Nichiha. I referenced them earlier for a siding manufacturer. They're really growing in the market, and a lot of different types of panels. And they have selected Adfast to provide the sealants that will don't need to be painted because they're already the same color as their panels. Same with James Hardie. James Hardie, cement board, et cetera. A lot of different colors that are available. Over 100 plus colors available for James Hardie. We offer the PVC setting blocks, the backer rod, and various different sizes. You always want to make sure and use a backer rod that's going to be twice the size of 2 to 3 times the size of your joint, because you need to be able to compress it and put it in so that it stays in place. So if you have a 1-inch joint, you would want to go with minimum, 2-inch backer rod. So with foam products as well. I'm going to be giving another presentation on Friday. I hope you can come join us to discuss a wide variety of foam products that we have, where we have low VOC, some of the lowest on the marketplace actually in terms of safety, safety for users and for the environment, and also offer some great elasticity and elongation against the competition. So at our website, please come take a look, adfastcorp.com. We have calculation tools to help you with your takeoffs, et cetera, for your products to understand how much product will be needed. And, we can also, if you enter a manufacturer color, we will identify the Adfast color that will be a good fit. And then we'll say, provide actually the latest and greatest for us is actually to provide a good, better, best options for you for color. And then one of the last things here, we do understand that we're in a situation right now where COVID-19 has been such a mess and is taking such a toll across the globe. We did, as a manufacturer, our leadership actually made the determination back in March of 2020 to fully convert over one of our production lines to start making hand sanitizers and hand gels, so sprays and gels. In addition to masks, et cetera. And so we offer this pretty much at cost to all of our customers and even those who don't currently purchase products from us, but would like to be able to try to stay safe. So hopefully you all stay well. And please turn to us if you have a need for any of these. We have 10-liter kits, very low cost on this material. Here's an example of the masks that we've made for construction workers. And lastly here, I know we're coming up on time for this presentation, but some examples of some projects that we've been doing, which are really, really cool projects. And as I click through these, I'll go ahead and open it back up. Are there a couple questions that I could help out with, or has it been a pretty quiet group?
Yeah, it's been pretty quiet. I think your presentation was pretty on point and answered pretty much all the questions. I don't see any active questions as of right now. But as you go through
the last
these,
presentation then. Yeah, right.
Yeah.
Quiet groups today.
But yeah, so as you said, you'll also come back to talk about your products a little bit more on Friday. So
Right.
that might be something also. And you'll be in the marketplace for the whole year, actually. So I think that's where people can go and find you and ask questions on top of your website that you presented. Maybe we can give it a couple seconds, but it doesn't look like we have a lot of questions about this.
Okay.
With that being said, the presentation will be made available in the marketplace, so questions might come at that point. And if you're watching this right now as a pre-recorded session, just know that you can go talk to the Adfast to Adfast in the marketplace.
We'd be happy to provide consultation for you or for any of your colleagues at no cost. You don't have to use Adfast to get consultation. We're trying to bring knowledge to the marketplace and happy to do so. Thanks very much for your participation today and attendance today. Please do join us on Friday, and I hope you have a good rest of the virtual show.
Yeah. Well, thank you for that, and see you on Friday.
Okay.
Bye-bye.
Bye now. Thanks.